Okay, let's say we were solving x squared equals 64. So this is going to work just like other math problems do. So what is the opposite of squaring something? It's taking the square root of something. So I need to make it a single x, so I'm going to take the square root of both sides. So I'm going to have x is equal to, and like 64 is a perfect square, so I know that this is 8, but let's say I didn't know. So let's come over here and let's do the factor tree method. So I would say, okay, this is divisible by 2, so I've got 2 goes into 64 32 times, and then I'm going to simplify 32. So again, I've got 2 goes into 32, how many times? So that one is 16, and 2 goes into 16 8 times. 8 simplifies to 2 and 4. 4 simplifies down to 2 times 2. So the reason we do this is so we can say, okay, pairs go out. So I've got one pair of 2's, 2 pair of 2's, 3 pair of 2's. So if I were to take the square root of, let's see, 2 times 2 is 4, right? So that means this is going to, square root of 4 is 2. So I'm going to take a single 2 out of all of these because I'm really just taking the square root of 4. So now I've got, what's 2 times 2 times 2? Well, 2 times 2 is 4. 4 times 2 is 8. So x is equal to 8. So this works every time. Okay, now let's say that we have x squared is equal to 48. So as soon as you see this x is squared, we know that we're going to have to take the square root because that's how you undo the squaring part. Okay, so I don't think 48 is a perfect square. So I'm going to go ahead and write down my x. And so I'm going to write down 48 over here. So I'm going to do my my prime factorization. So I've got 2 times 24. 24 is 2 times 12. 12 is 2 times 6. And 6 is 2 times 3. So I'm going to circle my pairs. So pairs go out and singles stay home. So I have a 2 and a 2. So that's going to be 4 square root of 3. Now there's another way that you can look at it because I'm really got the square root of 48, right? So you can try to find two numbers that you can multiply together that'll make 48, but the trick is one of them has to be a perfect square. And because I've already found this one, I know that it would be 16 times 3, so then I can write the square root of 16 and the square root of 3. So what's the square root of 16? 4. And then I can't take the square root of 3, so that's just going to stay there. So for me, the factor tree method always works. I struggle to come up with the two numbers to multiply together where I can take the square root of one of the numbers.